Hey scholars, welcome back to our last section of chapter 20 when we're looking at how can we best deal with water pollution. And we're going to have to look at preventing it, obviously, maybe working with nature to help treat sewage as well, so cutting our resource use as well. So let's take a look at it today. We need to reduce surface water pollution from non-point sources, which it has to do with fertilizers and pesticides and things coming off of cropland. So we got to reduce erosion, keep cropland covered with vegetation at all times. Which also would help with sediment running off and erosion. But reducing the amount of fertilizers, maybe plant some buffer zones along the vegetation along the rivers and streams to help stop some of those fertilizers and pesticides from actually getting into the water system itself, and also use organic farming techniques, which allows for no use of fertilizer or pesticides. So those are a couple of things that would help with non-point sources. Also using pesticides prudently or sparingly, and helping to control runoff again through buffer zones and things like that. Also, tougher pollution regulations for livestock operations. We don't don't necessarily think about cattle and horses and things polluting, but when they defecate, that comes along with bacteria as well that can cause some major oxygen depletion problems for an aquatic system. So we got to deal better with animal waste overall. So laws can help reduce water pollution from point sources. We've had the 1972 Clean Water Act, which helped out a lot with figuring out where to stop point source pollution coming from specific spots. It was amended in 1987. The Water Quality Act formed the base of the U.S. efforts to control pollution of the country's surface waters. The Clean Water Act sets standards for allowed levels of key water pollutants and requires polluters to get permits limiting how much of various pollutants they can actually discharge into aquatic systems. So that's one thing. They're also, the EPA is experimenting with a discharge trading policy of different pollutants, but it says under this pollution program, a permit holder can pollute at higher levels than allowed in its permit if it buys credits from permit holders who are polluting below their allowed levels. But the problem with this is this could allow pollutants to build up over time if you don't try to at least regulate even further. Hopefully they set those different amounts so very, very low, so it doesn't take as much. It takes longer to build up over time. But still, remember, without dealing with those pollutants, if you allow those pollutants, it can build up in a system over time. As far as the case of the U.S.'s experience with reducing its point source pollution has helped tremendously. Because of that Clean Water Act. We've seen water systems in the U.S. met health standards, 70–94% of them meet health standards as far as water systems go, which is pretty high compared to other countries, that's for sure. Some lakes and streams are safer for swimming or fishing. About 36–60% of lakes and streams are safe to swim in or to fish. So that's still much better. But again, we still see treated wastewater still producing algal blooms, high levels of mercury, pesticides, and other toxic materials in fish. So we have to be very, very careful. Even though the water itself might be safe, it doesn't mean the organisms necessarily in it are safe as well. One of the case studies also is reducing point source pollution. The leakage of gasoline storage tanks into groundwater, that has had a major effect in actually getting out to our lakes and rivers and getting into those systems, and had some major problems with groundwater itself, which is where we get most of our water from. Some people think we should weaken the Clean Water Act. Some people think we should strengthen it. I'm on the one side that strengthen it. I don't know about you, but as far as the percentages go, 79–94% met health standards. That's not 100%, and this is not a whole lot. This is very low to me. If it's below 50% or close to it, we need to do something more than to help with our swimming and fishing. All right, so let's take a look at sewage treatment. So individually, we produce waste as Americans, as human beings, and so we got to figure out how to deal with that waste before it gets into a water source. So we have two different types of methods. One of them is a septic tank system, which I'll describe, and I'll post some more videos about it below from other places on YouTube. Wastewater or sewage treatment plants are the second one. That deals usually in city. So we're going to look at all three of these different types of sewage treatment. The primary, which is the physical filtering out. The secondary, which is using aeration and a little bit of bacteria and some settling out. And then also your tertiary or advanced sewage treatment, including bleaching or chlorine, adding chemicals to the water to help kill off any other bacteria that might still be in there. So let's take a look first at the most simplest of forms, and this is one that I have in my house and a lot of people outside of city limits have. This is called a septic tank system. Basically what it is all your toilets come through one pipe and enter into what we call a septic tank, which basically has a manhole cover. It has a little area for gas being trapped, some area for scum, and some area for wastewater itself, and then sludge at the bottom. And what happens is you have to get this pumped out every 5 to 10 years or so to get the sludge out so it doesn't build up and then overflow. That's caused you real big problems. But the whole purpose of it is for the sludge to sit there. It will build up over time, but there's also bacteria in there kind of helping with decomposing. But the wastewater, the stuff that's coming out of your toilet, actually comes through here, gets deposited into this perforated pipe. So there's little bits of wastewater leaking out all the time. And that what happens with that is it gets to the ground, and the bacteria itself can help decompose that and break it down naturally. There's also a vent pipe because there are bacteria in the tubes in the wastewater breaking things down, producing methane, so you have to release some of that as well through a ventilation pipe. So that's kind of basically how the septic tank system works, using your own natural filtration in your yard to actually clear out and break down some of the waste that you produce in your home. This is a little bit more invasive. It's more for larger scale, for city limits. This is your sewage treatment plant. And we have one here in Onslow County, and eventually I'm going to go take a video there and do a Dill-Man versus Wild segment from there, but maybe I'll do that over the summer. But let's take a look at how it works overall, and we'll post more videos from other places about how this works. So first of all, raw sewage comes through. It has the bar screener, which filters out large things that shouldn't go on the toilet, like I don't know, G.I. Joes. I don't have those anymore. Those are my day of toys. Little figurines or toys or marbles or stuff that, condoms, things like that shouldn't be flushed down the toilet and gets filtered out by this bar screen. Then that's taken and removed and put into the landfills. The grit chamber is where actually there's some settling out going on. It kind of like goes through and there's some grit going on there. It kind of settles out there. And eventually the settling tank where the sludge then goes down goes to a sludge digester out to a drying bed that once it dries gets put into a big truck and then taken to the landfill and deposited. What happens also though, that as the settling tank moves through, as it settles out in these grit chambers, settling tank, then the water moves to an aeration tank, which allows for bacteria to thrive and help decompose some of that stuff. There's also things that are going to fall out there. Then it goes to another settling tank, and anything left over after that decomposition process gets put in there. And then eventually the tertiary is chlorine disinfectant tank, and then even added bleach to the water. And then it could then be put into a river, lake, or ocean. That's kind of the primary, secondary, and tertiary would be adding bleach on top of chlorine to help kill off bacteria and other pathogens that might be in there. Then it's deposited into rivers and lakes. So we can improve conventional sewage treatment. This guy by the name of Peter Montag is an environmental scientist. He decided to remove toxic waste before it goes to the municipal sewage treatment plants, which would help with how they work efficiently. Reduce the use of waste of toxic chemicals, and also using composting toilet systems. Very similar to a septic tank, but a little bit different. Also using wetland-based sewage treatment systems. So having all of your areas near wetlands, because wetlands do deal with pollution and at least waste of nitrogen and phosphorus very well. John Todd, another biologist, science, he used working with nature and treating sewage. Basically he saw that sewer water flows into passive greenhouses. This is his system. And the passive greenhouse, then the solar energy and natural process remove and recycle the nutrients for plant growth. And those are used for a diversity of organisms that can be used. And I think it shows you a picture of it here. Yeah, it does. Right here is his passive solar. Obviously, they're all living on hydroponics. And these plants are flourishing on basically wastewater. Now, will it smell perfectly good? Probably not. But plants are filtering out a lot of those nitrogen, phosphorus, phosphate ions to use in order to do their plant growth. All right. There are sustainable ways to reduce and prevent water pollution. In developed countries, we have a bottom-up political pressure to pass laws because we don't want to deal with our own feces and the smell. In developing countries, there's little to reduce water pollution. China has a very ambitious plan to cure pollution and water scarcity by recycling water in smaller treatment plants in all cities, but it's still a long way to go. Their water is still horrendous right now as far as cleanliness and quality. Solutions: prevent groundwater contamination at all costs, since that's where we get our water from, and the ground helps purify the water for us, at least the subsurface water. Reduce non-point runoff. That is one of the most dangerous forms and hardest to control. Reuse treated wastewater for irrigation and growing crops. Find substitutes for toxic pollutants. Work with nature to sewage. So looking at using nature either through wetlands or through greenhouses, like we saw with Mr. Todd. And then the other one is to reduce air pollution, because once it comes out of the air, it goes in the water. Produce the 3 R's of reducing, reusing, and recycling water itself, and reduce poverty, which would also help slow population growth. Those two things would help tremendously. And the last thing, what can you do as an individual is, fertilize garden and yard plants with mature or compost instead of commercial or inorganic fertilizers. And we have a compost pile right outside of this classroom to use and help with our agri-science classes. Minimize your use of pesticides, especially in your bodies of water. So try not to use those sparingly. Pull weeds if you have to. As far as large scale goes, kind of hard to, but maybe you can, work with your type of organic farms around you. Prevent yard waste and from entering storm drains. Do not use water fresheners in toilets because those can cause problems. It's hard to filter those out. Do not flush unwanted medicines down the toilet. Those are very hard to filter out through the filtration system we have set up, either through your wastewater treatment plant or your septic tank. And do not pour pesticides, paints, solvents, oils, antifreeze, other weird chemically products down the drain or onto the ground because they are very, very hard to deal with as far as wastewater goes. Anyway, I hope you enjoyed our section on wastewater itself and water pollution. We'll see you guys next time.